Question 5d, Part 1. Use the fact that tan alpha minus beta equals tan alpha minus tan beta over 1 plus tan alpha times tan beta to show that 1 plus tan n theta times tan n plus 1 theta equals cot theta times tan n plus 1 theta minus tan n theta. Let alpha equal n theta and beta equal n plus 1 theta. Given tan alpha minus beta equals tan alpha minus tan beta over 1 plus tan alpha tan beta, then 1 plus tan alpha tan beta equals tan alpha minus tan beta over tan alpha minus beta. Now, replacing the alpha with n theta and beta with n plus 1 theta, we have 1 plus tan n theta tan n plus 1 theta equals tan n theta minus tan n plus 1 theta over tan n theta minus n plus 1 theta. And that equals tan n theta minus tan n plus 1 theta over tan negative theta. And tan is an odd function, so we have tan n theta minus tan n plus 1 theta over negative tan theta. So multiplying the numerator and the denominator by negative 1, we have tan n plus 1 theta minus tan n theta over tan theta. And of course, 1 over tan theta is equal to cot theta. So this equals cot theta multiplied by tan n plus 1 theta minus tan n theta as required. Part 2. Use mathematical induction to prove that, for all integers n greater than or equal to 1, tan theta times tan 2 theta plus tan 2 theta times tan 3 theta plus plus tan n theta times tan n plus 1 theta equals negative n plus 1 plus cot theta times tan n plus 1 theta. The first step is to show the statement is true for some value of n. And in this case, the smallest value of n that we can test is n equals 1. Now, when n equals 1, the left-hand side of the statement equals tan theta multiplied by tan 2 theta. And notice that this is the tan of a double angle, which we'll need to work with later and express it in terms of the single angle or just in terms of tan theta. And the right-hand side of the statement equals negative 1 plus 1 plus cot theta multiplied by tan 2 theta, which equals negative 2 plus cot theta multiplied by tan 2 theta. And expressing cot theta in terms of tan theta and tan 2 theta in terms of tan theta, this equals negative 2 plus 2 tan theta over 1 minus tan squared theta multiplied by 1 over tan theta. And this tan theta and this tan theta will cancel, so I'll just cross them off there. And this equals negative 2 plus 2 over 1 minus tan squared theta. And adding these two terms together by finding a common denominator, we have negative 2 multiplied by 1 minus tan squared theta over 1 minus tan squared theta plus 2 over 1 minus tan squared theta. And adding the two numerators together there, we get negative 2 plus 2 tan squared theta plus 2. So the negative 2 and the positive 2 will cancel. And we end up with just 2 tan squared theta over 1 minus tan squared theta. And that equals tan theta multiplied by 2 tan theta over 1 minus tan squared theta, which equals tan theta multiplied by tan 2 theta, which equals the left-hand side. Now the left-hand side equals the right-hand side, hence the statement is true for n equals 1. Next, we assume the statement is true for n equals k. That is, tan theta, tan 2 theta, plus tan 2 theta, tan 3 theta, plus plus tan k theta, tan k plus 1 theta equals negative k plus 1 plus cot theta, tan k plus 1 theta. Next, we show the statement is true for n equals k plus 1. From the left-hand side of the assumption, we have tan theta, tan 2 theta, plus tan 2 theta, tan 3 theta, plus plus tan k theta, tan k plus 1 theta, plus the next term along, which is tan k plus 1 theta, tan k plus 2 theta. And this statement can be simplified using the assumption, so that equals negative k plus 1 plus cot theta, tan k plus 1 theta, plus the next term along, which is tan k plus 1 theta, tan k plus 2 theta. which equals negative k plus 1 plus cot theta tan k plus 1 theta plus, and I've put this in square brackets, cot theta multiplied by tan k plus 2 theta minus tan k plus 1 theta minus 1, and that's from part 1. And we get that by rearranging this equation and then replacing n with k plus 1. And this equals negative k plus 2 plus cot theta multiplied by tan k plus 1 theta plus tan k plus 2 theta minus tan k plus 1 theta. So this minus 1, or this negative 1, can be brought into this bracket here. So that's why it becomes negative k plus 2. And we have tan k plus 1 theta cancelling with negative tan k plus 1 theta here, which equals negative k plus 2 plus cot theta tan k plus 2 theta, but n equals k plus 1, hence k equals n minus 1. So replacing the k with n, we have negative n plus 1 plus cot theta tan n plus 1 theta, which equals the right-hand side of the original statement. Therefore, by the principle of mathematical induction, the statement is true for all integers n greater than or equal to 1.